Now we're going to do finding volt and current for each resistor that is in parallel. First thing we do again, as we did in series, you find the total resistance. But in parallel, the equation is the total resistance is R to the -1. The resistance is all to the -1 power added together and then taken to the -1 again. So 1 to the -1, 2 to the -1, and then all that to the -1 again. It turns out my total resistance is 0.55 ohms. Step number 1. Step number 2. Find total current. Total current, I use Ohm's law, but I use total numbers. So Ohm's law equals V equals I times R. I rearrange it. So this will be V total over R total. The total voltage is right here, 6 volts. The total resistance is 0.55. And it turns out that my total current flowing around that circuit is 11.01, but I'm around 11 amps. Now that I know, based on how they wired these resistors in parallel, I know how much current is allowed to flow, 11 amps. I know 11 amps will come home. Now, right here, it divides. And then it comes down here, and it divides again. And then it comes down here. It's like if you had three water hoses connected together, and some would go down one branch, some would go down another. But the same amount is not going to go down each one because these are different rated resistors. Think of this as a whole lot more resistance, so less water. If it were water in a hose, less water here, a little bit more here, and most here. It's like having crimps in a water hose. Okay, so we've done the first 3 steps, RT, IT, draw it in. This is where you need to know in your head, if you have got to know this, that in a parallel circuit, the total voltage drop for that parallel section is equal to the voltage drop across each branch. In series, it was additive. Here, it's equal. So the voltage drop across this guy and the voltage drop across this guy and this guy is all 6 volts. They are equal to the total. All right, now I want to find current. So I'm going to use Ohm's law again, but I'm going to use it just around these individual ones. So I want to know the current for the 1 ohm resistor, or this one right here. Don't I know his V and R? Per Ohm's law, it is, voltage is 6, the resistance is 1, the current going down there is 6 amps. I for the 1 ohm is 6 amps. I for the 2 ohm. I equals V over R. I'm going to write it up here so you know. It's just Ohm's law rearranged. So what's the voltage drop for the 2 ohms? 6. What's the resistance? 2. So the current going down that branch is 3 amps. And finally, the last one, the current for the 3 ohm resistor is the voltage that goes across it, voltage drop, over the resistance, and that turns out to be 2 amps. Just the opposite. Now remember, the voltage drops were all equal in a parallel circuit. But in a parallel circuit, the total current flowing out, which is 11, is the sum of all the currents that go down the different branches. So it'd be the sum of the 1 ohm, the current going down the 2 ohm, plus the current going down the 3 ohm. And of course, 6, 7, 8, 9, 10, 11, and that equals 11. These are, oops, sorry. These are things that you have to know.